All right, let's talk about one of the most incredible unsung heroes inside every computer, every phone, every device you own. It's this tiny piece of code that works nonstop, making billions of decisions every single second, and you probably don't even know it's there. We are talking, of course, about the CPU scheduler. Seriously, have you ever stopped to think about it? Right now, you're watching this, but your computer is probably also downloading something in the background, your email is checking for new messages, music might be playing. There are dozens, maybe hundreds of things happening at once. So how on earth does one single processor core juggle all of that without, completely falling apart? Well, the answer is a tiny but absolutely brilliant traffic cop living inside your operating system. And its only job is to decide which one of those hundreds of competing tasks gets to use the CPU at any given nanosecond. It's like the world's busiest air traffic controller, but for the microscopic world inside your computer. So here's what we're going to cover. First, we'll look at the CPU's crazy juggling act. Then we'll get into the era of fairness with something called CFS. After that, we'll see why fairness isn't always enough and meet the new kid on the block, EEVDF. And finally, we'll wrap up with what this means for the future of scheduling. Okay, so let's really set the stage here. The whole game for a scheduler is to create an illusion. The hardware, your CPU core, can really only do one single thing at a time. That's it. So the scheduler has to juggle tasks so fast that it feels like everything is happening at once. It's an incredibly high-speed act, and if it slips up even a little bit, well, that's when your computer feels sluggish, or your mouse gets jerky, or everything just freezes up. All right, so for more than a decade now, the way the Linux world has tackled this chaos has been guided by one big idea: fairness. Just pure, simple, unadulterated fairness. And the scheduler that made this idea a reality is fittingly called the Completely Fair Scheduler, or CFS. Now, CFS has been the absolute workhorse for basically all Linux systems since, get this, 2007. Just think about how long ago that was in tech years. Your Android phone, the servers that run the internet, maybe even your smart TV, chances are, for years, they've all been relying on this one piece of code to manage their brains. So what's the big idea here? What makes CFS completely fair? Well, its goal is to pretend that it's running on a mythical, perfect CPU. Imagine a processor that could literally run every single program at the exact same time, giving each one a perfectly equal slice of its attention. Now, obviously, that's impossible. No such CPU exists. But the genius of CFS is that it models its decisions on this impossible ideal. So how does it do it? How does it actually achieve this? Well, it's actually pretty clever. It keeps track of a number for every single task, called its virtual runtime or vRuntime. You can just think of it like a stopwatch for each program. Every time a program gets to use the CPU, its stopwatch ticks up. And the scheduler's one and only rule is super simple. Always, always run the task that has the lowest time on its stopwatch, the one that's run the least. It is, by definition, completely fair. But here's the twist. What if being completely fair isn't always the smartest play? What if focusing only on fairness ends up causing a whole bunch of other, messier problems? Well, that's exactly what the Linux kernel developers started to discover. See, a scheduler's life is way more complicated than just divvying up time. It's also got to worry about things like maximizing memory cache, which is just a fancy way of saying keeping important data close by so things run fast. It has to think about power management to make your laptop battery last longer. And these days, it has to deal with crazy hybrid CPUs that have a mix of big, powerful P cores and smaller, efficient E cores. The list of responsibilities just goes on and on. So to deal with all this extra complexity, the developers had to start bolting things onto CFS. They added all these special rules and exceptions to its pure, simple model of fairness. And what you ended up with, in the words of one of the top kernel developers, Peter Zelstra, was a bunch of icky heuristic code, which is basically a programmer's way of saying messy, fragile, complicated patches and workarounds that are a nightmare to manage. It was clear something had to change. And that's where our new challenger enters the ring. Its name is EEVDF. And it's not just a small change, it's a whole new way of thinking. It's a move away from that single-minded focus on fairness and towards something smarter, a philosophy built around deadlines that's much better suited for the kinds of computers we use today. And this really shows you the core difference in a nutshell. On one side, you've got CFS, with its simple idea of absolute fairness. It's always asking one question: who has run the least? That's it. But then you look at EVDF. Its philosophy is about both timeliness and fairness. It asks a much smarter two-part question. First, which tasks are actually owed some CPU time? And then, of that group, which one needs to run the soonest? It's a subtle shift, but it changes everything. And here's a really cool piece of trivia for you. EVFVD, it's not a new idea at all. The core algorithm was actually laid out in an academic paper way back in 1995. Isn't that wild? It's the perfect example of how a brilliant idea can just sit on a shelf for decades, waiting for the right moment and the right problems to finally come along so it can shine. Okay, so the secret sauce for EVDF is this one key concept called lag. You can think of it like a bank account for CPU time, for every single program. If your lag is positive, it means the system owes you time. You've got credit. If your lag is negative, you've used up more than your fair share. You're in debt. And this one simple number, this lag, is the key to how EVDF makes all of its decisions. And the decision process itself is really elegant. It's a simple four-step dance. First, it calculates the lag for everything that wants to run. Then it looks only at the eligible tasks, the ones with a positive lag, the ones that are owed time. For that group, it figures out a virtual deadline for each one. And finally, it just picks the tasks with the earliest deadline. That's it. So simple, but so powerful. And this is where the magic happens. Think about tasks that need to be super responsive, like moving your mouse cursor across the screen, or the audio for this video. They need tiny, quick bursts of CPU time. Well, under EEVDF's system, those kinds of tasks naturally get earlier deadlines. They just automatically get prioritized. And the best part? It happens without any of that special, icky code that had to be bolted onto CFS. The elegance is baked right into the algorithm. So you might be thinking, great, CFS is out, EEVDF is in, problem solved. But it's not quite that simple. This isn't a case of just flipping a switch. What we're seeing is a very careful, very deliberate evolution, not a sudden revolution. And it's happening right now in the open by the Linux kernel community. And this timeline really puts it all into perspective. You've got the idea for EVDF from back in '95. Then you have CFS, the reigning champ since 2007, and it wasn't until March 2023 that the first big patch set for EVDF was posted. Now, with Linux 6.6, it's finally here as an option you can choose. We are right in the middle of this story. And there's a very good reason everyone is being so careful. Just listen to what the developer Peter Zylstra said about it. He said it completely reworks the base scheduler, placement, preemption, picking, everything. I mean, this isn't just a minor tune-up. It's like replacing the entire engine of a car while it's still driving down the highway. You absolutely do not rush a change like that. So, how's it performing? Well, the initial results are really promising. People are finding that it schedules a lot more consistently than CFS, and it's showing a bunch of latency wins, which is great for things like gaming and audio. But it's not a silver bullet just yet. There's still a mix of wins and losses in different performance tests. There's still work to be done. And really, that's the big takeaway here. This is a fundamental change to a piece of code that millions, maybe billions of devices rely on to be perfectly stable. So the process of testing and tweaking and proving that EVDF is ready to take over, it's going to be slow and it's going to be careful. As the developers have joked, there is no deadline for this, virtual or otherwise. You know, this whole story is just such a fascinating peek into how technology really evolves. An idea can be king for over a decade, and then slowly a new philosophy comes along that's better suited for a new generation of problems. It really makes you wonder, doesn't it, what other fundamental parts of the technology we use every single day are just waiting for a rethink? What's the next big idea that's been sitting on a shelf since 1995, just waiting for its moment?